The roots of the education are bitter, but the fruit is always sweet. So never think that the education is going to be a waste. It is definitely going to give you the fruit in the future, and that is always sweet. That is the saying of the great Aristotle. So please act upon. Now, the moist heat, the third parameter is steam under normal pressure. It includes pure steam and tyndallization is a procedure. Pure steam with boiling water at normal atmospheric pressure, that is free steam at 100 degrees centigrade. Many of you must have seen in your houses and kitchen. It is used to disinfect selective heat labile culture media in the lab, which decompose if subjected to the high temperature by the other way of sterilization of heat, like dry heat and other. Steam is provided by the traditional Koch and Arnold steamer or by multi-purpose autoclave. And steam under normal pressure, the tyndallization procedure, also called fractional sterilization or intermittent sterilization. It was developed by the John Tyndall, a man of science, genius, pioneer, man of many qualities. An exposure of the steam at 100 degree temperature or below for 20 to 30 minutes on 3 consecutive days. The main theme behind is that all vegetative cells and some spores are killed during the first heating. Now, the resistant spores germinate into the vegetative form. These are being killed in second and the third heating. Alternate is by one exposure of 90 minutes, and it is a fractional method of sterilization and done by Koch and Arnold steamer. And here, that is the simple steamer that do produce the steam, and it is the photograph of John Tyndall. He said it is a fatal as it is cowardly to blink facts because they are not to our taste. So the Koch or the Alder steam sterilizer is here. One can see the lid of that, and here is the metallic cylinder, and here is the conical flask which have been put inside, and here there is a perforated shelf, and here there is a water that is going to cause the tyndallization procedure. Now, the fourth parameter is steam under high pressure. In steam under high pressure, bacteria are more quickly killed and it distributes heat to the all parts of the sterilizing vessel. Steam above 100 degrees centigrade or saturated steam is more efficient sterilizing agent than the hot air because it has greater lethal action of the moist heat, quicker in heating up the articles to be sterilized. It can penetrate easily porous material such as the cotton wool stoppers, paper and the cloth wrappers, bundles of the surgical linen and the hollow operators. These all can have the reach of the heated steam to their depths and to make them sterilize. Autoclaving is the process of sterilization by saturated steam under high pressure more than 100 degree centigrade. So it is carried out in pressure chamber called an autoclave, a device like fancy pressure cooker which is being used in the houses and kitchens. Autoclaving involves heating liquids, that is media or the solid, to the 121 degrees centigrade under steam pressure. Materials must be heat resistant. It is used in most hospital and microbiology laboratories. Steam is kept at a pressure of 15 pound per square inch psi in excess of the atmospheric pressure to obtain a temperature of 121 degree centigrade. And here is the autoclave, and here is the structure of that steam supply jacket and the culture medium which is put inside. And as one can see, the steam is coming in, and then steam is exhausted outside and to the drain. So this is autoclave being used most of the time for sterilizing the instruments, the other thing, linen, which is not being sterilized by the other way. So the fifth way after the heat is radiation, like ultraviolet light and X radiation is used to sterilize heat sensitive atoms. These kill microorganisms by damaging the DNA of the microorganism. Two types of radiation are used, non-ionizing and ionizing. Non-ionizing radiation include infrared rays, ultraviolet rays, and microwave radiation. And ionizing radiation include gamma rays, X-rays, cosmic rays, electron beams, or high energy rays. Here one can see the radioactive isotope that is releasing the gamma rays. This is the most popular, simple, easy, controlled, and widely applicable. The other is electron beam accelerator, which is going to discharge E-beam, that is the short treatment time, high dose rate, no waste product, and the other are the X-rays. These are high depth penetration, good dose uniformity ratio. So these are being used, the radiation. Number 6 is the filtration. It works by physically trapping the particles larger than the pore size, just like a sieve, and retain the smaller particles, sterilize solutions which can be damaged or denatured by the heat or the chemical agent. So filtration is the safest method for them. Most commonly used filter is composed of nitrocellulose. Pore size for filtering bacteria, yeast, and the fungi range from 0.22 to 0.45 micron meter. For sterilization of the intravenous fluid, sera, sugar solution, or antibiotic used for the preparation of the culture media, which cannot be sterilized by the other way of sterilization. Here one can see the filter vessel, the filter, and to the vacuum pump, which just sucks the liquid, and that is the sterile flask which is containing the fluid which is coming out after the filtration. These are the different type of the filters which are being used for the different purposes. Now, number 7 is the pascalization, or the high pressure processing, HPP. It is the method to preserve and sterilization of the food. Products are processed under very high pressure, hundreds of the megapascal, causing death of and inactivation of the enzyme in the food and destroy the spores at the low temperature. HPP treatment is applied at the room temperature and preserve shape, color, and nutrients of most of the foods. And pascalization is useful on the acidic foods such as yogurts and the fruits. Here one can see the high pressure processing, and there is the chamber, and the packed food is just put inside, and that is the pressure vessel, and that is the carrier basket, and the pressure transmitting fluid that is just here, and that puts pressure on the food, packed food, which is put inside. And one can see the different kind of the foods and the vegetables can be put inside, and to have the sterilization by the high pressure processing. Now the number 8 is ultrasonic and sonic vibrations. Sonic waves can be used as bactericidal agents which employ ultrasound, usually from 20 to 40 kilohertz, to vibrate a fluid. These produce high energy hydraulic shock waves, temperature as high as 10,000 degree Fahrenheit, and hydrodynamic pressure as low as 10,000 psi. Physically, this process physically loosen and remove microorganisms and debris from the surface of a contaminated instrument, and these sonic waves are effective against bacteria, spores. This method is nowadays routinely used to clean surgical instruments and the dental instruments at the dental clinics. And here are the ultrasonic devices which are responsible for causing the sterilization of the instruments and the dental procedure. Can you believe that the water is coming from the tap and tap have got no connection to the water line, but it is coming. It is either fact or imagination, but whatsoever it is very good to see that. Now, coming to the other group, physical agents, now we are coming to the chemical agents. These are of 3 types. Number 1, agents that damage cell membranes, and that include surface active agents or the disinfectants, phenol and phenolic compounds. The second group is agents that damage proteins. These are the acids and alkalis. Number 2 are the alcohols. Number 3rd agent is agents modifying functional group of nucleic acids and proteins. These include 4 subgroups. These are heavy metals and their compounds, oxidizing agents, dyes, and alkylating agents. Now I am going to tell one by one in detail. Now, number 1, agents that damage cell membrane. These are surface active agents, disinfectants, phenol and phenolic compound. First, the surface active agents. These possess hydrophobic, water repelling and hydrophilic attracting groups, and also called soaps and detergent, which are being very commonly used in our washrooms and other areas. These disrupt cell membranes. These can be cation and anion or a non-ionic group. Chlorhexidine or iodine detergent scrub should be used if hands are contaminated. Now, phenols and phenolic compounds. These have antiseptic, disinfectant, bactericidal or preservative properties. These affect plasma membrane, alter membrane permeability, inactivate enzymes, and denature proteins at 1 to 2% aqueous solution. Phenol, basically the carbolic acid, was first used by the Joseph Lister, father of the antiseptic surgery, in 1867. I have told you his wards were very clean because of use of this antiseptic carbolic acid. That is not used today because too caustic is skin irritant and has got strong bad odor which is very repellent. Chemical derivatives of the phenols are called phenolics. And here one can see the different kind of the soaps now coming in the different bottles and different ways, liquid and other form. So these are soaps and detergent, and this is the carbolic acid antiseptic advance of the later 18th century, and now not being used because of its bad smell. Now, the second group is agents that damage proteins. These include acids and alkalis and alcohols. First, the acids and the alkalis. Acids and alkalis, these kill by denaturing proteins, permeabilities, aromatic acids. Other acids are used as preservative in food and pharma industries. Weak organic acid like citric acid, weak organic acids are bacteriostatic and fungistatic, so that is being used in the food industries. Alkalis like sodium hydroxide, calcium hydroxide, sodium bicarbonate have antimicrobial action. And the agents that damage protein continue. Number two is alcohols. It includes ethyl alcohol, ethanol, isopropyl alcohol, methyl alcohol, and propanol, methylated spirit, which is being used very commonly for antiseptic purpose. These rapidly kill bacteria, including tubercle bacilli, fungi, but no action on the spores and the viruses. HIV is susceptible to the ethyl alcohol and isopropyl alcohol 35%. Ethanol is used to clean and mechanically wipe microbes off the skin as skin disinfectant. Before immunization, injection or venipuncture, methyl alcohol is effective against fungal spores, but its vapor is toxic and inflammable, not good for the open wounds, but for the skin antiseptic purpose it is being used. Here one can see the different alkalis and different acids, and here that is ethyl alcohol as used mostly as spirit, methylated spirit. This is the photograph, looks like to be two small children, but these are not the photograph of these two small children. These are the photograph look like to be the children made by the God Almighty. These are basically two figs, the fruit of God. These two figs just by chance have the shape of the two small kids. So the God Almighty's creation is wonderful. Now, agents, third group, agents that modify functional groups of proteins and the nucleic acid. These include heavy metals and their compounds, oxidizing agents, dyes, and alkylating agents. The first, heavy metals and their compound. These include mercury, silver, arsenic, zinc, selenium, and copper were used as germicide for many years in the past. They combined with the proteins, often with their sulfahydryl groups, and inactivate these bacteria. These also precipitate and denature the cell proteins, and these include mercury chloride, very toxic, so limited use, bacteriostatic, ineffective against endospores, silver nitrate, highly bactericidal for gonococcus, for prophylaxis of ophthalmia neonatorum due to the gonococcus. In burns, topical application of the silver sulfadiazine has reduced the mortality in burn patients. Copper sulfate as algicides used in the pools and the fish tanks to just sterilize them. And selenium kills fungi and their spores for the fungal infection in dandruff shampoos. And the zinc as zinc chloride mouthwashes, zinc oxide as antifungal agent in the paints is used. Here one can see the mercury chloride, the silver nitrate, and the silver nitrate drops are being put in the eyes of the kid who have got the ophthalmia neonatorum because of the gonococcus. And this is the zinc, and here the copper sulfate and the selenium, which are being used as different kind of sterilizing compounds. Now, oxidizing agents, orthocard peroxygens inactivate cells by oxidizing free self-hydryl group, so inactivate the enzymes of the bacteria. These oxidize cellular components of the treated microbes, disrupt the membranes and the proteins. Most useful antimicrobial agents include hydrogen peroxide, halogens like iodine and pyodine, very commonly being used, and iodophore, hypochlorite, and chlorine for the water purification, ozone, benzyl peroxide, peracetic acid. Iodine is used as skin disinfectant and chlorine as water disinfectant. Unique disinfectants, their activity is bactericidal and effective against sporulating organism. Here one can see the hydrogen peroxide solution and liquid iodine, and here it's the sodium hypochlorite and the chlorine for the water disinfection, and that is for the disinfection of the other things. So, number 3 are the dyes. These stain microorganisms inhibit their growth. One is crystal violet or gentian violet, used as a skin antiseptic. Positively charged dye molecules bind to the negatively charged phosphate group of the nucleus of the bacteria, and malachite green, a component of the Lowenstein-Johnson or algae medium for Mycobacterium tuberculosis. The dye inhibits the growth of unwanted organism in the specimen, which is used for the growth of Mycobacterium tuberculosis. There are two groups of the dye used as the skin and the wound antiseptic. One are the aniline dyes, the other are the acridine dyes. Both are bacteriostatic in the high dilution but of the low bactericidal activity. Here one can see the crystal violet and the malachite green, these are the dyes, aniline dyes and acridine orange dyes, these are also being used as antiseptic. Now, the last group is alkylating agents. These are grouped into aldehyde, which include formaldehyde, glutaraldehyde, and the other is ethylene dioxide. The lethal effect of the aldehydes and ethylene dioxide results from their alkylating action on the proteins and just acting on the nucleic acid, so that going to kill the bacteria. Here one is able to see the formaldehyde being used, and that is ethylene dioxide gas sterilizer for the instrument, that is just sterilizer to do the sterilization of the many of the things being used in the operation theater. Now, we have done the sterilization and the disinfection. We have to check whether the sterilization has been complete or proper, up to the mark. So these are called sterilization monitoring. It is routinely done by the combination of the physical, chemical and the biological parameter. Physical, that is, we check the cycle time, temperature and the pressure of the gadget which is being used to sterilize the thing. Chemical, heat or chemical sensitive inks that change color when germicidal related parameter present, that is class 1 to 6. Different kind of the strips and different kind of the charts are being used to check the sterilization is complete or not. Then biological, bacillus spores that directly measure the sterilization. These are the different kind of the bacillus spores are used to check the sterilization of the different gadgets. So that is how we are going to monitor the sterilization. And here one can see the different charts, the different colors, the different strips, the different inks, and different monitor things. That is sterilization monitoring supply that is going to check whether the sterilization is complete or not. So that is the end of the lecture for disinfection and sterilization, and I hope so you will like it, and if you will like it, you will please subscribe it and share it with the others. And if there is any question or query, please do not hesitate to ask me on my numbers given. And thank you very much for with me